Hello, my name is Rob Reynolds. Welcome to Mat-073. Today we're looking at the fourth section from Chapter 4. We're going to be exploring how to factor some trinomials, oftentimes one of what students consider the most difficult lessons. I'll try to simplify things for you. First of all, I want to teach you about some rules about signs. And so there's basically four ways that I could rearrange the addition and subtraction signs. So let's look at the last signs first. If this last sign is positive, then that's going to tell me two things. The signs inside these parentheses are going to be alike, and I need to add in order to get factors of 6 that add up to 5. Down here I'm finding factors of 6 that differ by 5 because this is a minus sign. So start with that last sign first. This says signs are alike, so either they're both pluses or both minuses, and that first sign tells me what they both are. So in this case, they're both positives, and following the same pattern here, this says signs are alike, but this time they're both negative. So coming down here, this means signs are different, and instead of adding, I'm going to find factors that differ by the middle term. So factors of 6 that differ by 5 are different than factors of 6 that add up to 5. We'll explore that in a moment. Right now I just want to look at the signs in here. One's a plus, one's a minus. That's all I know is the signs are different. And then this first sign doesn't tell me what they both are anymore. This first sign tells me what the larger term is. And this gets a little bit more difficult when I have a leading coefficient, but for today's lesson, we're only going to look at problems that have a leading coefficient of a 1 and practice this first. So in my next video, I'll change that a value, or that a term in the ax squared plus bx plus c. The leading coefficient will not be a 1 later. So we're going to go for the larger term, and if the larger term is positive, I'll stick an L there, and then if signs are different, once again, because of this minus sign, here it says the larger term is negative. So here I wrote it out a little bit neater so you can see what's going on. Let's actually plug in the numbers. Factors of 6 that add up to 5. Well, factors of 6 are 1 and 6, 2 and 3. So up here I would choose the 2 and the 3. And of course, x times x gives me the first term if you remember the FOIL method. So it gets pretty easy once you get the signs in there. Down here, it says I need factors of 6 that differ by 5. So instead of using the 2 and the 3, this time I'm going to use 1 and 6. But remember, this tells me the larger. And I'm not going to say the larger number. You'll get in trouble if you say larger number. It's actually the larger term, because I got to look at outer terms and inner terms, and again, it gets more difficult when you have a leading coefficient other than 1. But it's pretty simple. Factors of 6 that differ by 5, I got to click a 6 and a 1, and this says put the larger number. Well, I want to make the larger factor, the larger term, a 6 and a 1, and my first terms are x and x. So same thing here. X and x I know is the only way to get x squared. Factors of 6 that differ by 5 are still 6 and 1, but this time the larger is negative. So I'll stick this 6 here, forcing the 1 there. But remember, you can always check these by foiling these back together and checking the solution. So here goes. First example. Factors of 20 are 1 and 20. I'd list them in order. 2 and 10. 3 doesn't go in there. 4. And as soon as you hit a number on the right side, then I know that I've listed all of the factors. So I'm going to slap down 2 sets of parentheses. The only thing that's going to give me x squared for the first terms is x and x. Then I look at the factors of 20 that add up to 12. And factors of 20 that add up to 12 are 2 and 10. This says signs are alike. They're both negative. So I'll put some negative signs in there. And we'll choose, it doesn't matter. You could go 2 and 10. You could go 10 and 2. It doesn't matter because 5 times 4 is the same thing as 4 times 5. So either answer A or answer B works perfect for me. And here's how the author worked it out. Again, the order that you multiply those in does not matter. So factors of 20, again, I'll list them again. 1 and 20, 2 and 10, 4 and 5. I've listed all of them. But this time I need factors of 20 that differ by 1. So this time I'm going to use the 4 and the 5. Put those in first before you put the signs in, because I don't know if it's plus minus or minus plus. All I know is that the signs are different. And the larger term is negative. So if I look at the outer terms is 5x, the inner terms is only 4x. I need to make sure that that's a negative and that's a positive. So when I do the FOIL method, I'll get a negative x right here. So this is the larger term. So I know the larger term is that negative. 5. 5 is larger than the 4. But don't go to the larger number. Again, that will get you into trouble. It's actually the larger term, which is outer terms and inner terms, forcing this to be a plus sign. Again, this is okay as long as the leading coefficient is a 1. My next video will show you where the leading coefficient changes a little bit. So this one says factors of 4 that add up to 2. Well, this adds up to 5. This adds up to 4. There are none, so I would just say this is not factorable. And sometimes when things don't have any factors, we call them prime. So you could either say not factorable, or you could just write the word prime. I can't find factors of 4 that add up to 2. So here are the rules that the book is recommending, but I've given you my own rules, so you can pause the video and check this out, how the book recommends it, but I found that students find this pretty successful. Be careful, don't let these y's freak you out too much. The process stays the same. We just need to find the first term is going to be x and x, and then the last term is going to have a y in it because I've got a y squared term in it. Everything else follows the suit. I'm going to list factors of 28 that differ by 3 is what I'm looking for. Factors of 28 that, and don't worry about this negative. All that means is the larger term is going to be negative, so don't worry about factors of 28 that differ by negative 3. I would just say factors of 28 that differ by 3. So factors of 28 are 1 and 28, 2 and 14. I know 3 doesn't go into 28 because the sum of the digits isn't divisible, because 8 and 2 adds up to 10, so 3 doesn't go in there. I'll try 4, and it turns out that 4 and 7 does. Just continuing, 5 doesn't go in there because it doesn't end in 5 or 0, and 2 and 3 would have to work in order for 6 to work, and then I've hit a number over here. So I know I've listed all of the factors, and these are the only ones that I have to choose from, but I got to find things that are factors that differ by 3. So I think I'm going to choose that 4 and 7. It doesn't matter if I go 4 and 7 or 7 and 4, but I just need to make sure that the larger term is negative right here. And so that forces this to be negative, and this says signs were different, so this has to be a positive. And again, here's how the author chose to solve it. So recap, last example, and then I'll recap, give you a couple more examples. My rules that I've given to you about reading the signs only works if the leading coefficient is a positive number. So here I'd reorganize this a little bit by multiplying through by a -1, and let's bring this highest degree up front. So x squared minus the 2x minus the 24. Notice if I distribute this, I'll get back to the original problem. So I'm going to rewrite it. So I have a new problem in here. I'm going to try to factor this yellow. So remember, my rules only worked with a leading coefficient of a positive 1. So that's why I factored out that -1. And now I'm just going to concentrate on the yellow. This says factors of 24 that differ by, because this is a minus, factors of 24 that differ by 2. So here comes the factors of 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5 doesn't go in there, and then I hit a number over here and I'm done. Factors of 24 that differ by 2 are 4 and 6. So how I choose to put those in there, I don't care if you go 4 and 6 or 6 and 4. There's no y squared term this time, so I just stick with this. X and x, this says signs are different. The larger term is negative, and so the larger term is -6x, forcing this to be a positive, and you have to hang on to that -1. Good. Author got the same solution. So again, just kind of capping some things. This is of the easiest type because I need to find factors of 20 that add up to 9. And factors of 20 that add up to 9, I'll list them over here. 1 and 20, 2 and 10, 3 doesn't go in there, 4 and 5, I found them. And you can go 4 and 5 or 5 and 4, it doesn't matter. In fact, this one, it really doesn't matter because the signs are alike and they're both negatives. So if you know how to read the signs, factoring is not that difficult. You can do it fairly quickly and do it in your head. So the leading coefficient, this has that y squared thing again. So I think the trick here is to go x and x, but remember, you're going to stick a y and a y there. And now I'm just looking for factors of 48 that differ by 2. So, I know it's going to be 2 high numbers. If you don't want to list them all, we don't have to. If you can just come up with 6 and 8, because I know that they're 2 high numbers, so I'm not going to start with 1 or 2 or 3. I know 3 goes in there because 8 and 4 adds. But I don't want to figure all that out. I think I can just come up with two higher numbers. 6 and 8 differ by 2. And it doesn't matter if you go 6 and 8 or 8 and 6. Just make sure that the signs are different and the larger term is negative, which forces this one to be negative and this one to be positive. And again, the author agrees with me here. If you have an x squared term, instead of x and x, we'll just, excuse me, an x to the fourth term, we'll just go x squared and x squared because you rewrite the base and add the exponent. Factors of 15 that differ by 2 are 3 and 5. Again, you can go 3 and 5 or 5 and 3. Just make sure signs are different. And the larger term is positive. So put a plus sign with the 5 because it's larger than 3. But again, I'm not just looking at the numbers. We're actually looking at outer and inner terms. You'll be sorry if you just keep looking at the larger number. It's not the larger number, it's the larger term. And then remember, my rules only work if the leading coefficient is positive. We can have other things besides 1. I know in this video I'm always showing you that the leading coefficient is a 1. My next video we'll change that number from a 1, but make sure that it's positive in either video. So negative 5x minus 14, and now I need factors of 14 that differ by 5. So I'm going to choose 2 and 7. Doesn't matter if I go 7 and 2 or 2 and 7. X and x gives me the x squared. Signs are different. The larger term is negative. So I'll put the negative with the 7, forcing the 2 to be positive. And final solution is not this. Don't leave your answer like this. Leave your answer with a negative 1 factored out. They're just showing you that A is equivalent to B and C, but I don't prefer B and C. Please leave it in completely factored form. If you have any questions, please feel free to email me.